All right, guys. So good morning. This is the day I'm sure many of you have been waiting for. It's certainly the day I've been waiting for a long time, where we finally get to start solving quadratic equations by factoring, right? So we spent all that time factoring. We haven't really applied it yet, other than just, in factoring itself. We spent some time solving quadratics, right? We did a day solving quadratics graphically. We did a day solving quadratics using square roots. But our primary way of solving quadratic equations is going to be by factoring. Today I think it would be a good day maybe to run through the do now, right? So you have five trinomials and a binomial that you should be able to factor. So if you're going to do that, I would pause it. You can factor, and then you're going to check it out with me. So I'll do the factoring now. All right, so that last one really isn't going to come into play maybe for a couple days, but hopefully we should remember how to factor these, right? We said we're going to use, in a standard trinomial, right, where the coefficient of x squared is 1, we've got our product, we've got our sum, right? So I was looking for two factors of 10 that add up to 7, and the ones that I found were positive 5 and positive 2. And I did the same for the rest of them. Number 5 is obviously a difference of squares, where we're taking the square root of the first term, the square root of the last term, and we're multiplying their sum by their difference. So before we actually get into solving quadratics, we need to talk about what's called the zero product property. Right? So the way I would introduce this in class normally is I would say, well, if somebody told you that a times b was equal to 0, what would you say? And hopefully someone would raise their hand and say, well, it means that either a is 0 or b is 0, or possibly both. And that's true. Right? So if a times b is equal to 0, then one of those expressions at least has to be equal to 0. And that's going to lead us to what's called the zero product property. Now, how that's going to apply to solving by factoring is this is going to be treated as a, and this is going to be treated as b. So if this quantity, this first quantity, times this second quantity is equal to 0, then either that first quantity is equal to 0, or that second quantity is equal to 0. And that'll allow us to solve those equations, and that's what's going to allow us to solve these quadratics by factoring. So this is definitely something that I would make sure that I have in my notes, because we're going to basically be spending the next 2 weeks talking about solving quadratics by factoring. All right, so I'm going to try to do as much of this as possible as I kind of would in class, okay? So this is something where I introduce it in class. I say, all right, guys, here's a quadratic equation. So obviously one thing we could do is graph it. I wouldn't want to graph something like this because it's not going to fit on a 10 by 10 grid because of the constant. So I'd say, all right, what do we think? Who thinks they could come up with the solutions? And then I would go further and I'd say, well, there's going to be a positive solution and there's going to be a negative solution. And at some point, somebody would raise their hand and say, well, if I use x is equal to 5, it works. And I would say that's correct. And then eventually someone else would say, well, negative 3 also works. And I would say that's also true. And then I would show you how to check it. So I'm not going to have really the time or the space, unfortunately, to check every single one. I mean, if that's something you'd like me to do in the future, give me some feedback on the classwork and we'll talk about that. But I certainly can give you a check for this one. So if we check the first equation, and ideally I would rewrite the original, and I'm substituting 5 as x. And I'm following order of operations, and it is really important that all of the terms that should be in parentheses, like the terms we're substituting, are in parentheses, especially this term here, especially when it's negative. So I'm going to rewrite my original. I'm going to substitute, and I'm going to evaluate using order of operations. And again, if this wasn't in parentheses, when you do the operation, particularly if you use your calculator, it is going to do it incorrectly. So that's what my check is going to look like. Now, as far as your guidelines for homework, you're going to follow the directions. If I tell you solve and check, you're going to solve and check. If I tell you just to solve, then we're just going to solve. You don't need to check. Okay, and of course, if there's any, if you need more clarification about something, just reach out. But that's what it would look like. Now, obviously, that's not the most efficient way using guess and check. Okay, but it works, right? In other words, the solutions work, right? The method is not efficient, but we know that 5 and -3 do work. Now, what's another way I can get 5 and -3? I can get that by factoring. All right, so if I want to clear all this out, I can say, how would I factor this? Well, the way I would factor this is I would use x minus 5 times x plus 3. So let me go back to my zero product property. My zero products property told me that if this times this was equal to 0, then one of those two has to be equal to 0, so I can what we call set them both equal to 0 by making two separate equations. And that's exactly what I'm going to do. So I can say either x minus 5 is 0 or x plus 3 is 0. So if I add 5 on both sides, I get x is 5. And if I add -3 on both sides, I get x is -3. So this is precisely why we spend so much time on factoring. And I'm going to ideally write this as a solution set. All right, so x is -3 or 5. Now again, those are the same solutions that we came up with or we would have been able to elicit by using guess and check, but it's going to be much more efficient based on our knowledge of factoring. All right, so as far as your steps to solve a quadratic, and again, this is something that I would definitely recommend you guys getting in your notes. All right, so let's go over the steps that we're going to take to solve our quadratics by factoring. All right, so the first step is, if necessary, transform to standard form. Standard form means it's equal to 0. So we'll work on that a little bit more tomorrow and the next day. Step 2 is factor the left member. That just means the left side. It could be the right side. Generally, we move into the left side, but it could be either side. Set each factor containing the variable equal to 0, right? So that's what we just did, right? This is where we set each factor equal to 0. And then we're going to solve each of the resulting equations, right, which is exactly what we did. Let me go back here, right? We solved the first equation. We solved the second equation. We write our answer as a solution set. And then as far as the check, again, that's something where if I assign the check, we'll do it. If not, then we're just going to solve it, and we can kind of cut out step 5 after that. All right, so let's start with some pretty simple ones, right? So it says x squared plus 3x plus 2, so I'm going to factor, right? So that hopefully we should know to be x plus 2 times x plus 1. We're going to what we informally call split it up. So I'm just thinking about the things that normally happen, when I'm doing this lesson in class with you guys. Technically, mathematically, we say we set each factor equal to 0, but informally we say we split it up. So x plus 2 can be equal to 0, or x plus 1 can be equal to 0. And this is generally a simple one-step equation, though we will at some point see two-step equations, maybe a little bit later today. So my solution set should be -2 and -1. All right, as far as how I write the solution set, it doesn't matter the order. I'm just trying to anticipate questions that we sometimes ask, right? I generally try to write the smaller solution first, though honestly it really makes no difference. So if I go back to my original here, and if I check, -2 squared will be 4, plus 3 times -2 is -6, plus 2 is 0, so 0 equals 0. And if I was to check with -1, right, -1 squared is 1, plus 3 times -1 is -3, plus 2 is 0, so 0, 0. So that's not a formal check. I just want to kind of show, I just want you to understand that it works. Not that we're doing all this stuff and we're getting answers and then we're just moving on, right? So we can see that if I go back here, and if I substitute for -2, that it works, and if I substitute for -1, it works. All right, so let's take a look at the second one, right? So this one's going to be a little bit different. All right, so when I factor it, I get x minus 4 times x minus 4. Right, so this is what's called a perfect square trinomial. In other words, I could just as easily write it like this. Which means technically, if I want to be really kind of fancy with it, I could do this using square roots. And I don't want to do that now because I'm going to try to keep things here really simple. And if you have more sophisticated questions about that, then we could certainly talk about it on Google Classroom. But I'm going to try to keep things as simple as possible here. So perfect square trinomial means that its two factors are the same, which means the two equations should be the same, which means our two solutions should be the same, meaning there really should only be one solution. Now, technically, we say that there's two solutions, but they're two equal solutions, which is the same as saying that there's one. So I'm going to go to split it up, but I'm going to realize that it's kind of going to be silly for me to solve the same equation twice, so I won't. I'm just going to solve it once, right? Both of the equations will be the same. So I get x is equal to 4, right? So if I want to express it as a solution set, it would just be 4. And again, if I want to just kind of casually go back and take a look, if I do 4 squared, that's 16 minus 32 is negative 16 plus 16 is 0. So since this is a perfect square trinomial, since the factors were the same, since the equations were the same, there is only one solution, and that solution is positive 4. All right, so I can probably skip the first one. Let's just cut to the second one here, right? So when I factor this, it's going to be x minus 9 times x plus 8. And again, I'm going to set each factor equal to 0, or you want to say split it up, we can do that. So my first solution should be positive 9. And my second solution should be negative 8. So when I write it as a solution set, I should have negative 8, positive 9. And again, if I just want to kind of go casually back through it, negative 8 squared is 64, minus negative 8 would be plus 8, is 72, minus 72 is 0. And if I want to run through it with 9, it's going to be 9 squared is 81, minus 9 is 72, minus 72 is 0. So we'd see that both of those will check as well. All right, so for both of these, we're going to use difference of squares. Right, so for the first one, I should have x plus 5 times quantity x minus 5. So now I set each factor equal to 0. So my first solution should be x is negative 5. And my second solution should be x is positive 5. Meaning I could express this as x equals plus or minus 5. And if I wanted to express that in a solution set, it would be the same. And obviously, if I go back and check, 5 squared is 25, minus 25 is 0. Negative 5 squared is 25, minus 25 is 0. So if we have a difference of squares, you're always going to have opposite roots, which means we're always going to end up with that plus or minus there. And we could do that with the second one as well, except with the second one, we're going to end up for the first time with the two-step equation. Right, so the way we're going to factor this using difference of squares is 2x plus 9 times quantity 2x minus 9. So when I split it up now, I actually have to solve a two-step equation. So my first one, I add negative 9 on both sides and divide by 9. So I'm going to leave this as a fraction, right? In general, we prefer fractions to decimals, and the work here is going to look almost identical. And again, I can express this using plus or minus. And if I wanted to do it as a solution set with those braces, it's going to look almost identical, plus or minus 9 halves. And if I really want to be thorough and check it, when I go back, 9 halves squared is going to be 81 fourths, times 4 is going to be 81, minus 81 is 0. And that works whether the 9 halves is positive or negative. So again, if we're talking about a difference of squares, we're always going to end up with that plus minus in our answer at the end because the roots will always be opposites. All right, so this is where we do our now try, where you could have your classwork. All right, so again, if you're doing this, the right way, which I'm really hoping everybody is, this is where you do a pause, you'd work these out in your notebooks, you'd hit unpause, and then you'd see me work through them. So for the first one, hopefully we did x minus 7 times x minus 5. And then we've got x minus 7 is 0. So I get x is 7. And I get x is 5. For the second one, we've got a difference of squares. So I end up with plus or minus 11 when all is said and done. And I just don't have a lot of space, otherwise I would write out your solution set as well. So here I'm going to factor this as positive 18, negative 2. So my two solutions should be positive 2 and negative 18. And for this one, I should be using negative 20, positive 3. All right, and again, if you want a little bit more practice, and this is not something that you have to submit, but if you want a little more practice, you can try these 4. You can check in with me tomorrow on Google Classroom. We'll be back tomorrow looking at quadratic equations that are not in standard form, that are going to require us to what we call transpose.